Drug Synthesis Cost Analysis by Mike Bailey, Julia Madsen, Taylor Reese, Samantha Poirier, and Mike Mignosa. These are the two equations we'll be using. Equation 1 is to create the intermediate. Equation 2 is to create the final product. At Site 1 for Equation 1, only 269.4 grams of sodium hydroxide is available in each 7-day period. We would have to wait 7 days in order to obtain enough NaOH to create the equation, resulting in 8 days wait to gather enough materials. And in order to run Equation 1, we would need to wait another 7 days. The final time to run Equation 1 is 15 days. For Equation 2, we need 403.9 grams of sulfuric acid, but only 300 grams of it is available in each 7-day period. In order to get enough sulfuric acid, we would have to wait 8 days. Then to run the entire equation, we would have to wait another 7 days, resulting in a total time of 15 days. For Site 2 Equation 1, we need 258.4 grams of phenol, and the most we can get is 250 grams in each 7-day period. We would need to wait 8 days in order to get enough material. Due to the site's aging, it can only produce 90% of Equation 1 at one time. Due to this, we would need to increase our materials, which would cost extra, and or run the equation twice. The equation to run one time is 7 days. If we choose to run the equation a second time, we'd have to wait 3 days and then wait another 7 for the reaction to finish. With the second run and increase in materials, the total time would be 25 days. With just increase in materials in one run, it would be 15 days. For Equation 2, because of the site only yielding 95% of Equation 2, we need to increase our materials in order to create more of the intermediate from Equation 1. This will cost extra, but it will not take any additional time. Total time to run Equation 2 is 7 days. Site 3, Equation 1. Because the phenol available is only 81% pure, we will need to increase the amount of phenol we use. The equation needs 100% pure phenol. There is plenty of phenol available to use, but we would just have to pay for the extra needed. Total time to run Equation 1 is 7 days. For Equation 2, there is a manufacturing variability, so the percent yield of Equation 2 varies between 79% and 92%. Due to this, there is no way in knowing beforehand what the final yield will be. If we undergo the second equation and the final yield is only 81%, then we would need to redo both Equation 1 and 2 in order to undergo Equation 2 again, resulting in time wasted and money lost. Total time to run Equation 2 with 2 runs would be 9 days, with not including time needed to rerun the first equation. Total time to run Equation 2 with 1 run is 7 days. Site 4 Equation 1. We need 258.4 grams of phenol, but the site only allows 250 grams, so it is not possible to run Equation 1 at this site. If that was not a problem, we would still need to wait 5 days extra in order to obtain enough carbon dioxide. To run the equation, it takes 5.5 days. Total time to run Equation 1, if there was enough phenol, is 10.5 days. For Equation 2, we cannot use this site because it is not able to store enough of the intermediate to create 500 grams of the final product. The facility only allows so much, and we would need to use 2 sites to create enough of the final product. With all this in mind, we chose to do Equation 1 at Site 3 and Equation 2 at Site 2. This graph shows the amount of each material we need. The most we need is sulfuric acid, while the least we need is carbon dioxide. This graph shows the cost for each material. As you can see, the most expensive for every site is phenol, but the least is different at each site. At Site 1, the least is sulfuric acid. At Site 2, it's sodium hydroxide and sulfuric acid. At Site 3, it's sodium hydroxide. And at Site 4, it's carbon dioxide. This graph shows the shipping cost from supplier for each material. At Site 1, the most expensive is carbon dioxide, while everything else is barely anything. At Site 2, the most expensive is sodium hydroxide, while again everything else is barely anything. At Site 3, there's very low costs, as well as at Site 4, the costs are really low. This graph shows the total costs. At Site 2, the shipping for all the material is most expensive. At Site 3, the materials altogether are the most expensive. But back at Site 2, The total for both shipping and materials is the most expensive. The cost to ship the materials for equation 1 at site 3 is $17,351.08. The cost to ship the materials for equation 2 at site 2 is $2,128.50. The cost to ship the supplies from supplier for equation 1 at site 3 is $1,060.92. For equation 2 at site 2, it's $600.24. To ship intermediate between sites is $46,401.30, for a grand total of $67,542.04 to make 500 grams of the new drug. Total time to create the drug is 14 days, using Site 3 to create equation 1 and Site 2 to create equation 2.